All right, we're going to continue our conversation about inequalities, but we're going to be talking about graphing these inequalities. So thinking about our keywords. Now, the first one we're going to focus on is our greater than symbol. This is our greater than symbol. It's a symbol we're all familiar with. We've talked about it, we've used it. And so thinking about those keywords for greater than, it could also be more than, larger than, above. But our main keyword is greater than because that represents this symbol here. So let's just make up a scenario quickly about greater than symbols. Let's imagine that the scenario said that Amy has more than $5. So let's write that. Amy has more than $5. So we have our keyword here, more than. So now the question I have is, does Amy have $5? No, she has more than $5. So we're going to have to put at 5 an open dot because she doesn't have $5. She has more than $5. So now which direction should we draw our line on the number line? Is it going to be this direction? Does she have 4, 3, 2, $1? No, she has more than $5. So we're going to go in the positive direction because she has $6 or $7, $8. So now that brings up another thing that we can talk about, and that is called our solution set. So let's write that down as well. Our solution set. Now our solution set, if Amy has more than $5, she has $6, $7, $8. And I'm going to put dot, dot, dot to represent that we can keep going because she may have $20, $200. All we know is that she has more than 5. She can't have 5, she can't have 4, she can't have any of these numbers, but she can definitely have anything greater than that. All right, so make sure you put this down in your notes. The next thing we're going to talk about is our keywords for greater than or equal to. Now, some may ask, well, why is that line underneath that greater than symbol? It's similar to when we're writing an equal sign, but instead of writing an entire equal sign, we use the greater than symbol and then write one line under it to represent or equal to. So now let's make a situation for this symbol. So our keywords we can use at least, minimum, no less than, no smaller than, but we know that this symbol is greater than or equal to. So let's imagine the scenario is this. Robert has at least 5 pairs of shoes in the closet. So in this particular scenario, at least is our keyword. So now the question is, if he has at least 5 pairs of shoes, can he have 5 pairs of shoes? Well, yeah. If he has at least 5 pairs of shoes, 5 pairs is an option. So, are we going to have an open dot or a closed dot? I think close dot because 5 is included in our data set. 5 is the number of pair of shoes he could have. But then it says he has at least 5. So could he have more than 5? Well, yeah. He can have 6, 7, 8, 10, 15. No matter what the number is, he has to have something at least 5. 5 or more. So could he have 4? No, he has at least 5. Could he have two? No, he has at least five. So five or more. So now for this solution set, we would have the numbers 5, 6, 7, and so on. We can go on forever. We know he has at least 5 though. All right, so now let's go back up to the top of our notes. Let's take a look at the next inequality symbol that we'll be using, and that is our open dot. Open dot, we can use less than, smaller than, below, lower than. These are some keywords. There's more keywords, but these are just a few. Now we know that this is our less than symbol. So now let's write a situation that would represent something using the word less than. So let's think about something school related. So less than 5 people need to finish the MI. So this is the test we took just a few weeks ago on math inventory, just to kind of see where you guys were at. And I'm saying that less than 5 people need to finish the MI. All right, so how are we going to graph this? Well, first off, our keyword here is less than. So now, less than 5 people need to finish the MI. Well, I know I'm going to start my graph at 5. Is this going to be an open dot or closed dot? Well, first off, less than 5 people need to finish. So, can 5 people need to finish? No, less than 5 people need to finish. So 5 is not included in the data set. It is an open dot because we don't need 5 people to finish. We need less than 5 people to finish. And so we'll go in the negative direction. So now, what values would be included in this solution set? Well, first off, 4 people is an option, 3 people is an option, 2 people, and so on. 1 or 0 at less than 5 people. So anything over here. Because 6 people need to finish? No, less than 5 people. So we couldn't be 6 people. All right, so now to the last inequality symbol. So the last one is less than or equal to. Once again, we have this line under the less than symbol, and this represents keywords here, at most. So that's the maximum, at most. No more than, this is the top. Don't spend no more than this at the store, your mom would say. Or the maximum amount you're going to be able to get is 1 cup or of juice or whatever. So no greater than. These are our keywords. So let's take a look at a scenario. So let's imagine you have at most 5 teachers before connections. You have at most 5 teachers before connections. And maybe I could even say classes. Instead of teachers, some people have 2 teachers in a class. So you have at most 5 classes before connections. So as we know, we're going to start at 5 because 5 is the number we're talking about. But now, is this going to be a closed dot or open dot? Well, at most 5 teachers or 5 classes at most. So that is our maximum. So we could possibly have 5. So 5 is in our data set. Can we have 6 before? 6 classes? No. Well, that's higher than 5, and 5 is the maximum. So the numbers that would be included are the numbers that are less than 5, because this is the top. And so what numbers will be included in our solution set? Well, let's write it out. 5 could be included because we may have 5 classes, 4 classes, 3, and so on. So I want to show you a cool little trick just so you remember. When looking at this, you can also say, well, which direction is my arrow going to go? Well, if I look at my arrow, let me use a different color. When I look at my arrow, I also notice that that is the same direction as my inequality symbol. Look at your arrow. It is the same direction as your inequality symbol. Arrow, same direction as your inequality symbol for each of them. But your variable would have to be first and then the number you're comparing. All right. I hope this video was helpful. I hope you took some great notes. You can always come back and rewatch this if you need to. Make sure you get all that information down, and I'll see you next time.